What happens when one of the most controversial vehicles ever built slams into a barrier at highway speed? Does the futuristic stainless steel body of the 2027 Tesla Cybertruck make it safer than traditional trucks? Or could all that toughness create unexpected problems? The answer is far more surprising than most people think, and by the end of this video, you might look at vehicle safety in a completely different way. The Tesla Cybertruck has never been a normal pickup truck. From the moment it was revealed, people debated everything about it. The sharp edges, the ultra-hard stainless steel exterior, the unconventional design that looked more like something from a science fiction movie than a vehicle designed for everyday roads. Supporters claimed it would be one of the safest trucks ever built. Critics questioned how such a rigid structure would behave in a serious collision. And that brings us to the biggest question. What actually happens when all that metal meets a real crash? Before we dive into the results, it's important to understand something about vehicle safety. Many people assume that the strongest vehicle automatically provides the best protection. It sounds logical. If a vehicle barely deforms during a crash, shouldn't that be safer? Not necessarily. Modern vehicle safety is actually based on controlled deformation. Engineers design specific areas of a vehicle to crumple and absorb energy before it reaches the passengers. The goal isn't to keep the vehicle looking perfect. The goal is to protect the people inside, and that's exactly why the Cybertruck creates so much curiosity among safety experts. As impact testing begins, the first thing everyone notices is the structure itself. Unlike traditional pickups that use more conventional body panels, the Cybertruck's exterior materials and construction immediately stand out. The truck appears incredibly solid, almost intimidating. As the vehicle approaches the barrier, expectations are divided. Some expect near-invincible performance. Others predict potential challenges due to the truck's unique design. Then comes the moment of impact. The collision is violent. Within fractions of a second, enormous forces travel through the structure. The front end begins managing crash energy exactly as modern safety engineering intends. While the exterior may appear exceptionally tough, what matters most is how the underlying structure handles the energy transfer. This is where many viewers are surprised. The Cybertruck isn't simply relying on brute strength. Advanced engineering beneath the exterior is designed to direct crash forces away from occupants and into designated structural areas. That's a crucial distinction, because surviving a crash isn't about winning against the barrier. It's about protecting human bodies from sudden deceleration. As the crash sequence unfolds, attention shifts toward the passenger compartment. This is where safety tests are truly won or lost. A vehicle can suffer visible damage and still perform exceptionally well if occupant survival space remains intact. And that's exactly what investigators look for. Door openings, roof integrity, steering wheel movement, pedal intrusion, airbag deployment timing, seatbelt effectiveness. Every detail matters. The Cybertruck's cabin structure becomes one of the most discussed aspects of the entire event. Maintaining occupant space during severe impacts is one of the most important safety objectives in modern vehicle design, but frontal crashes are only part of the story. Because real-world accidents rarely happen exactly as planned. Offset collisions introduce a completely different challenge. Instead of spreading forces evenly across the front, the impact energy concentrates on a smaller area. These tests are notoriously demanding because they expose structural weaknesses that might otherwise remain hidden, and this is where things become even more interesting. The truck must not only absorb energy but also prevent dangerous intrusion into the passenger compartment. Every inch matters. A small structural failure can dramatically increase injury risk. As engineers analyze the results, attention turns toward occupant protection systems. Airbags deploy in carefully calculated sequences. Seatbelts tighten instantly. Sensors process information in milliseconds. Most drivers never think about these systems. Yet during a serious crash, they become the difference between walking away and suffering life-changing injuries. The Cybertruck integrates a complex network of safety technologies designed to work together during emergencies. The effectiveness of these systems often matters just as much as the structural design itself, but crash protection isn't limited to what happens after impact. Some of the most important safety features work before a collision even occurs. Tesla has invested heavily in driver assistance technologies, collision avoidance systems, emergency braking functions, and advanced sensing capabilities. These technologies aim to reduce the likelihood of crashes altogether. Of course, no technology can eliminate risk completely, and that's why physical crash performance still matters. Now let's talk about one area that generates enormous public interest whenever an electric vehicle is involved: battery safety. For many viewers, this is the first question that comes to mind after a major collision. What happens to the battery pack? Modern electric vehicles are engineered with extensive protections surrounding their battery systems. Structural shielding, isolation mechanisms, monitoring systems, and automatic safety responses are all designed to minimize risks during and after severe impacts. The Cybertruck's battery architecture becomes a major focus of analysis because maintaining battery integrity is essential not only for occupant safety but also for emergency responders arriving at the scene. This area often receives less attention than dramatic crash footage, yet it may be one of the most important aspects of modern EV safety engineering. As testing continues, another factor begins attracting attention: vehicle mass. The Cybertruck is not a lightweight vehicle. Mass can create both advantages and challenges in collisions. A heavier vehicle often performs differently than smaller vehicles when forces are exchanged during a crash. However, increased weight also means greater kinetic energy must be managed during impact. This balancing act represents one of the most complex challenges facing modern vehicle engineers. The laws of physics don't care about marketing claims. Every pound matters, every mile per hour matters, and every engineering decision involves trade-offs. By this point, the initial shock surrounding the Cybertruck's appearance begins to fade. What's left is a deeper appreciation for the engineering questions that make this vehicle so fascinating, because the story isn't simply about stainless steel. It's about how an unconventional design adapts to decades of evolving crash safety science. And perhaps the biggest surprise is that the discussion becomes less about appearances and more about fundamentals. Can occupants survive? Can injuries be reduced? Can energy be controlled? Those are the questions that ultimately matter. Now it's important to be clear about something. Official crash test programs and safety ratings evolve over time, and specific 2027 testing results may not yet be publicly available depending on when you're watching this video. Responsible analysis means separating confirmed information from speculation. What we can say is that modern crash evaluations focus on occupant protection, structural integrity, restraint systems, crash avoidance technologies, and post-crash safety measures. Those are the standards every vehicle must face, regardless of how futuristic it looks, and that's where the Cybertruck remains one of the most intriguing vehicles ever tested. Its design challenges assumptions. Its construction sparks debate, and its crash performance forces people to think beyond simple ideas of strength and toughness. So are the results shocking? In many ways, yes. Not because the truck behaves like an indestructible tank and not because it completely rewrites the laws of physics. The real surprise is how much modern safety depends on intelligent engineering rather than raw durability alone. The Cybertruck demonstrates that protecting occupants requires far more than a tough exterior. It requires carefully managed energy absorption, advanced safety systems, structural planning, and countless engineering decisions working together in fractions of a second. That's what truly determines whether a vehicle protects the people inside. Now it's your turn. After seeing the Cybertruck's crash performance and understanding the engineering behind it, do you think Tesla's futuristic pickup lives up to the hype when it comes to safety? Or would you trust a more traditional truck design? Let me know your thoughts in the comments, and don't forget to subscribe for more crash tests, vehicle safety breakdowns, and automotive deep dives.